What I'm going to do today is talk to you about one of our greatest hack technologies. I've been working with Yahoo for almost 3 years now, working with our developer evangelist program, with our developer network, really working with the core APIs and services that Yahoo has to offer. And personally, I think that Yql is one of the ultimate hack technologies that you could possibly use in this 24-hour hack event, as well as in your personal development lives. So when you want to get some piece of data on the web or mash up multiple sources, it can be a very painful experience. You will go through the process of looking at API documentation, signing up for individual keys, signing up for all this stuff that you have to do to download the data and mash it up manually. Now that's where Yql comes into play. This is what the technology does for you, is make it easier to go through those steps. Make it easier to authenticate to particular APIs and services. And this is really the greatest benefit that we can see. And it looks like you are getting my lovely little, there we go. My lovely little screen desktop background, but here we go. This is the Yql API hack. What I'm going to go through today are a couple of main topics. We're going to take a look at an overview of Yql, what the actual hack project is, what Yql will do for you from a high level. We're going to jump into some specifics, going through how to build queries on the system, how to actually use one of our great sandbox environments in Yql. Then we're going to take a look at how to wrap your own API and service within Yql. Mash it up with Yahoo data, some external data feeds, or something like that. Then we'll take a look at one of the great pieces of data within Yql. That's the server-side JavaScript execute layer. This is going to allow you a huge amount of control over the data feed that you're bringing in. Then, I understand if you blank out over the talk, you're not listening throughout this entire thing. You just have to pay attention to that last slide when I go over some final lessons to get the gist of this talk. First off, let's take a look at the Yql overview. Really see what the service has to offer. So, I've been working with Yql for over 2 years now, and try to think of the best tagline for what the service does for you. And just simply put, it allows you to not have to reinvent the wheel. Now, I understand that you might want to build the ultimate scraping technology to grab image data from a page or what have you, but whether it's in this 24-hour hack event or your real lives, you have to prioritize. You have to utilize the best tools available to you to actually grab the data. So that's where Yql comes into play, and that's where Yql is going to provide you with a lot of benefit. You will see that it can quickly get and mash up data sources and provide them back to you in a uniform format. So don't reinvent the wheel. Utilize tools like this to your benefit. All right, so what is Yql? What does it do for you? Let's take a look at the actual workflow that we're going to see from Yql. First, we have the user. Now, this is you guys as developers or you guys as users of a web page. This is the starting point. Now, the user is going to say something like, I want to access Flickr photos. Now, Flickr is our photo sharing service. So I want to access Flickr photos based on some search criteria, like I want photos for a specific region, or I want photos based on some query. And that they're going to communicate this message to the Yql service via a standard REST request. So they're going to issue a request to the Yql service saying, I want this information. Yql as a service will say, okay, I understand your request. I understand that it's a valid request, but I have no idea what Flickr photos are. So what service is going to do is do a lookup on its standard Yql data tables. Now, the data tables are really just, think of them as configuration files. They're XML configuration files that tell the Yql service how to actually access data, like Flickr photos. So YQL tables will say, yes, I do indeed have a table available that shows you how to get Flickr photos from the web. So it's going to communicate this back with the service. The service will say, awesome, I have everything I need, all the configuration to say I can access Flickr photos. So it's going to make a communication request out to the Flickr services, or whatever services it may be using in the configuration file, and the web service, the standard web service, will respond back with the Flickr photos. When the service gets this information back, it might manipulate the photos. If you have some server-side JavaScript layer built into your table, it might only return back a certain number of results that you need, but it will always push it back to you in a uniform format, like JSON or XML. Whether the service provides that or not, you can have a feed that's dumping geographical information for Google's KML format, for instance, and it can convert it. So you can get this nice little flow giving you exactly what you need. And then that information all comes back to the user in a nice response back. Now, it's a good middleware layer between you and a web service, allowing you not have to do a lot of the heavy lifting to get started. So let's take a quick look at what YQL does to actually capture the data. So there's multiple different data feeds that YQL can leverage off of. And the way that the technology started was really just as a skeleton key for Yahoo technologies. So we said we have a lot of technologies within YDN that we want to make available, specifically around 63 different APIs and services. So we said we want to open this up and make it a lot easier for developers because API access can be painful. OAuth can be painful. All these systems that attackers have to go through on a regular basis can be painful. So we opened up all of our developer products within YQL, allowing you to access all that data through a standard method and not have to deal with all the pains of signing up for all these keys. But as a service then, it would be pretty useful for us, being Yahoo service. But we know that Yahoo doesn't offer every single product or every single development service that you could ever want to use. So we wanted to open this up to the web, allow you to access a lot more data. So we open this up to external data feeds, RSS, XML, JSON, any external data feed that you might want to leverage off of and pull back into the system and mash up with Yahoo data or other data, you can do that. There's even a screen scraping table, called our HTML table, which allows you to screen scrape pages based on an XPath to drill down to specific repeating values on the page. Very handy, just something to note. And finally, as external data feeds, that would be amazing. Yahoo data and external data feeds, good. But there's all these other APIs out there that we might want to leverage off of. So we open the system up even further in this concept called open data tables. This XML configuration wrapper that basically tells the YQL service how to access an external web feed, web API, go through authentication protocols, things like that. So all that information can be dragged in through YQL very easily. And I'll show you how to do that in a little bit. But as a fetching service, this would be an amazing technology on its own. But we wanted to make it more like a true RESTful service or mimic database functionality. So what we did was open up the service to not only allow fetching, but also setting and deleting data. So the YQL team built in insert, update, and delete functionality into the YQL table structure. So if you have a web API that allows that functionality of put, post, or delete, you can easily remove data or update data or add new records to web services. Like, let's say you have an external database that you want to update, a WordPress blog, for instance, and you want to delete a post off there or a comment. You can do that through YQL. You want to access Twitter and update your status. You can do that through YQL very easily without having to use their individual APIs. Now, the question that always comes up, because YQL mimics a lot of database functionality, it's the syntax that we use to showcase what YQL is. It's a SQL-like format. So the question that always comes up is YQL a database? Can you use create table on it? Can you store data within the service automatically? Is it a storage engine? And the simple answer to that is no. YQL is not a database structure. It is a web service that sits between the user and the web service, web API, the external data feed that you want to leverage off of. It just makes it so much easier to leverage off of these data sources. So it's such a beautiful technology in that. All right, so the overview we went through, you kind of have a good gist of what we're going to be talking about and what we're going to be looking at. So let's take a look at actual syntax, how you're actually going to implement all this technology. We're going to look at some of the queries and this beautiful sandbox environments that you're going to find so useful if you're working with this system. All right, so for fetching data, how many of you here know SQL? Or any database? Okay, a whole bunch of you. And those of you that don't know it, it's so intuitive that I could talk through all of this with you. So, if we want to fetch some data source from the web, the simple syntax that we're going to use in YQL is a select statement. We're so going to select some piece of data from a table. Now, the table might be an external data feed. It might be a web API. So if the API opens up and says you can search based on a query or you can search based on a title, that's going to be in the select statement where you select title, for instance. You can also select star if you want all the data returned back from the actual table. You can do remote filtering of the actual feed by putting in brackets afterwards 2 pieces of data, or 1. You have your starting point on the results that you want to return back, so start at the 0 value and return back 50 results. It's a good way of getting more than the standard 10 results that YQL might return to you. Now this is remote filtering, so let's say if you have 1,000 records or 1,000 pieces of data on an HTML page that you want to scrape out. You can implement some paging model so you only return back the first 100 results, and then give the option to the user to click next, and then run another YQL query to grab the next pieces of data. So this is a good paging model to be aware of. Then you can filter the data to get exactly what you're looking for using where, and or clauses. So just like a traditional database. Then you can do some local filtering using limit and offset. So unlike remote filtering, which just gets a certain number of results from a remote site, local filtering will actually filter results that are returned back. So let's say we have 20 results that are returned back. This limit and offset that's on the screen right now will return back 3 results starting from the 10th result. Now if we take a look at some of the other insert, update, delete functionality, insert's very easy as well. We have an insert into some table. In this case, it's a bit.ly URL shortener. The keys in the bit.ly URL shortener that we want to set, so our login API key and long URL, so what we want to shorten. Then we set our values to whatever the values of those fields may be. Update, where we're updating an existing record on some web API or web source. We would just say update the table name and setting a key to a particular value. You can set as many keys and values as you want. Then you can use the where, and or clauses to filter down to exactly the elements on the API that you want to update. Much like the delete command. So delete, you would just say delete from the table name and use where, and or clauses, just like you did with update, to drill down to the exact records that you want to delete. Now, one of the other great little pieces of information within YQL, within the table syntax that I want to cover, is the concept of subselects. Basically, all it really means is you're selecting some piece of data from one table based on the result sets of some other table. So in the case of this example up here, what I'm doing is I'm finding all geographical information from our GeoPlaces table. So this is Yahoo Geotechnologies, based on the location from my social profile on Yahoo. So I'm saying at the top level, select everything from GeoPlaces, which is going to give me latitude, longitude, the place name, the parent of the geolocation. So if I have a town, it would be the county level, then it would be the province or state level, then the country level as we go up the chain. So we're searching for GeoPlaces where the search text is located in my social profile. So my social profile, I'm extracting the location. So the location will to return back, in my case, Livermore, California. So we'll get geotechnology or geoinformation for Livermore, which we can then use to plot a map or search for Flickr photos based on our geolocation. Very easy stuff. All right, so I cannot really go into Yql without showing you some really great examples. So we're going to do some live demos here and show you exactly what you're going to be leveraging off of when you're using Yql. So over here, we have our beautiful Yql console at developer.yahoo.com developer.yahoo.com/YQL/console. Now what we're seeing up on screen, let me just show you a few pieces of data. Over here, up here, we have our statement that we're going to be running on Yql. So select, insert, update, delete, whatever we want. Over here, we have the data formats that are returned back to us, XML or JSON. Then we have the data that's actually returned. So this is the XML or JSON feed that's returned from the web service or external web API. Over on this side, we have some recent queries and example queries. So these are all very helpful for you to get started. Now down here, we have all the tables of data that you can leverage off of. Not sure if you can see it or not, but that number up there besides data tables says that we have 1,112 pieces of data that you can leverage off of. 100 or so are Yahoo technologies. All the rest are things like Amazon data, Facebook data. We have a ton of Google data. If you're so inclined, we also have a Bible table that you can leverage off of some information. So all this information is available to you. I suggest if you have a hack that you might want to leverage off of external data, take a look at what we have available. See if there's something that you can use here. It'll probably save you a lot of hours worth of hacking instead of having to work through all that. And down here, the most important bit, this URL at the very bottom in tiny little print is how to actually access the Yql service. It's a standard HTTP REST request. So you would issue a GET request to this URL structure. All right, so let me zoom back out here and show you a few examples. So let's say I want to scrape some data from the web. Now our HTML table at the very, very bottom, if we load up the data folder and go down to our HTML table, what's going to happen is it's going to load up a sample query. In this case, it's loading up the description of the table. So the description of the table is going to show just how to utilize the service. So let's go over to an example page that we might want to scrape, reddit.com. Let's say I want to parse reddit.com because I don't feel like going to the site and I just want to leverage it off of in my own data files or my own application. The pieces of data that you're going to need to know for how to drill down to only returning something like the title data is really some denoting factor on how to actually access these titles. So something unique, like a class. So let's go ahead and open up our inspector in Chromium. And then we can inspect these titles. Now we can see here that in the HTML, all titles are an anchor tag with a class of title. Perfect piece of data for us to be able to utilize our HTML table. And we have a nice little web outage. So let me show you exactly how this is going to look. So we would say select everything from the HTML table where the URL equals reddit.com and the XPath equals to any anchor tag that has a class equal to title. So that's really what we're going to be looking at to actually test the table out. But as the website is not actually producing very nice results, you can see the gist of it. Basically, what's going to happen is we are going to return back all the title data from the information. So we're going to return back all these pieces of titles as long as the wireless stays up. So it's a web API, so we have to actually leverage off of this this information. All right, so let's go back to the presentation since we're having a little bit of not so much luck with our live demos. And let's take a look at some of the other pieces of functionality within Yql. If you want to see some of the queries, please find me afterwards. I'd be happy to show you how to scrape HTML data, scrape Flickr photos based on geotechnologies, or do any of this information. Any sort of data that you want to leverage off of, I can show you how to do that very easily without having to go through all these APIs and services. So one of the pieces of data that is returned back that you would have seen in this live demo is Flickr photos. So under our flickr.photos.search table is the ability to search for Flickr photos. You can search based on information like geolocation, lat long. You can search by query. So you can basically search for Flickr photos for a particular region, like this region. Now, the data that's actually going to be returned back from Flickr, it looks like this. So each of the results will be a photo with pieces of data. Now, this is standard for the Flickr API. And it actually has a lot of information that we can utilize. But you don't see a URL up there. You don't see a URL to a photo. You don't see a URL to a user's profile. You don't see any of the sort of data that you're going to need to build Flickr photos. So keep in mind that data that's up there. We can construct URL structures based on those pieces of data. So actually, it's a lot easier because we have a lot of data in there that we can build. So based on the Flickr API, we can build a photo URL by having some static text marked up with some piece of information, like the farm or server, ID, secret, all this to build a photo URL. We have a photo page, so linking off like an image tag with that photo URL to a specific page which would show the full photo, as well as any comments or information. You can build that page URL. Then, if you want to give a link back to the owner's profile, the person who created the photo, which is always a good thing, I know. If you take a photo, you might want someone to link back to your profile just to show that you actually created it. And you can build the owner's profile based off this as well. So just by passing in the owner information. So using the pieces of data, this is how you would do it. All right. So the URL query structure that you're actually going to be using. So remember that URL at the very bottom of the console system that we're going to be working with. The actual REST call that you're going to be issuing with get, put, post, or delete. Well, there you have two URLs that you can leverage off of. There's query.yahooapis.com/v1/Yql, which is a private endpoint. And then all the URLs to access Flickr data or any public data, like geotechnologies, things like that, are all available under /public/Yql. So what's the difference between the two URLs? Well, first, the private endpoint needs to have OAuth authorization implemented. So you're going to need to go through this quite complex OAuth process, but I'll show you a trick for actually not having to do any of that, because OAuth itself can be a hack in its own, where you take all night building out that process, and if you aren't familiar with authorization technologies. So I'm going to show you how to mitigate all that and not have to deal with it. And then you have the public endpoint, which you can just call in a standard REST request. So you can issue in PHP a curl request, or most languages a curl request, PyCurl in Python, or URL lib open, .url open. JavaScript, you can use technologies like YUI3. You can even use jQuery. You know, it all leverages off that data. So within each of these URLs, we have a few parameters that are passed along the query string. So these are parameters that you would just tack on as key equals value, just like in a standard REST request as a get along the query string. These parameters our queue for the query. So that would be your select, insert, update, delete, whatever commands you might want to run. You'll have your format, so XML or JSON, whichever format you want back. You'll have your diagnostics, which diagnostics is a very helpful tool. Because if you set that, what's going to happen is you're going to get more information about the queries that you're running. Error logs, response time, which should be usually under 100 milliseconds. But if you have a service that's timing out, you can see it directly in the diagnostics. Now, if you're wrapping your own web API or web service, debug is going to be your saving grace. Because Yql console caches your Yql tables for a certain amount of time. Usually it's 5 minutes. But let's say you're making a bunch of hacks to your table, uploading it every single minute. It's going to be a pain because you're not going to see any of your changes coming up. You won't be sure if it's your error or the service's error. Set debug to true. That'll kill all the cache, and you won't have to deal with that. Then, lastly, you have a callback. The callback is just a JavaScript function name that you can use to implement JSON-P or JSON-PX, which is basically JSON or XML with a callback. What's going to happen is when the Yql service returns back its pieces of data, so this will be your JSON or XML data structure, it will execute that JavaScript function that you have implemented, much like an AJAX request, and the parameter that's going to pass in is the data structure that's being returned from Yql. Very easy, very helpful. So if you are leveraging off of a service that doesn't have these callback methodologies, then you can implement JSON-P and JSON-PX this way. So just some things to note. Now, I said that I would tell you a little bit of ways to negate all the issues with OAuth. First place, I've worked with partners who have implemented OAuth. Now, this is OAuth 1, not OAuth 2. I've had partners who have taken less than 3 hours to implement OAuth, people who understand authorization technologies. I've had people who, writing from scratch, have taken 2 to 3 weeks to implement it. Not something you want to try out and deal with on a 24-hour hack day. Just trust me on this. So, the way that you can mitigate this is by using one of the software development kits that we have available within Yahoo. So at github.com/Yahoo are a series of social APIs. Now, every single social API has a method call in it called Yql. The way that you instantiate all the OAuth session and actually having the user authorize your application, now this is only if you really need some piece of private data like a social profile or Facebook information or Netflix data because they use two-legged OAuth signing. You can utilize our software development kits in ActionScript, in Objective-C, Python, PHP, and Java. All these are available to you. If you're a .NET programmer, there are some samples on there as well to get you pretty much all the way along as well. It's in beta right now, but it will give you all the code that you need. Now, this is a simple way of not having to deal with OAuth, and I would suggest strongly that you don't. So let's see how Yql can actually run, how you're going to work with it. Now let's see if our little website is up and running now. Let's hope. If not, we'll do some offline online demo, a little bit of hack magic. Working but not working. Okay, so it looks like we're still down, but I'm going to show you exactly how you can build a query. So, going over my console, in a Python script, now this is going to be dead simple. If I create a new Python file, so yql.py, no, actually, that's my finished example in case I mess up. So let's not go into that one. Create a new file, and what you're going to do in order to build Yql, Python, PHP, what have you, I'll just show you in Python really quick, is utilizing the standard library, the Python standard library. You can utilize URL lib, which will allow you to run a GET request against Yql as a service. you can import JSON. Now, JSON isn't part of that standard library, so if you search for Python and JSON in your favorite search engine, which I'm guessing is all Yahoo here, right? Okay, so if you download, you can download that and just have the JSON files available to you. Now, the way that it's actually going to work is you can specify a URL, and the URL would be a string like the YahooAPIs.com. So APIs.com. So that would be your full RESTful request. So at the very bottom of the console system, I'm not going to type out the entire URL, but it's at the very bottom, just copy and paste that in, no problems. Then all we would need to do is open up a new file handler saying urllib.urlopen and pass in our URL. What this is doing is issuing a GET request to that URL structure, basically opening the file, or in this case, some sort of external web feed. Then we can specify the data that we want. The data would be our JSON. So we're converting a JSON structure. If we return back a JSON feed, if we return back an XML feed, we don't really need that. But in most of the cases, you're going to be returning JSON and dealing with that. So you can JSON read in the file handler .read. So you're reading in the contents of the file, whatever that might be. So basically leveraging off the web API. And then you can just simply print the data. Now, what you would see if I ran this in the console and it actually connected to the Yql service through the wireless connection is that the data structure or the raw JSON data would be displayed on the console using the Python script. It's very easy to do this. In YUI 3, you have this native Yql method built into the JavaScript layer. Now, if you are utilizing Yql, I strongly suggest that you stay for Reed's talk today on YUI and all the talks around YUI today as well. It's a very helpful language for being able to leverage off of visualization data and anything that you need to run with Yql. Where Yql is this awesome data representation, YUI is the very helpful visualization and data control layer. The two technologies work ideally together. All right, so that's a little bit about how to actually run the service. So now you know how you're actually going to be leveraging off of the data source. Now let's take a look at how to actually wrap your own web API. You're using our Yql open data tables, which are basically just an XML configuration. Using a standard table configuration, the XML node, a root table node specifying the XML namespace, we have two nodes in there that we care about, meta and bindings. This will basically tell the Yql service everything that it needs to know to access the web source or web API. Now, if we take a look at meta, it has a lot of meta information about the table. It'll have things like author information, sample documentation. And when I click on one of the tables in Yql, in the Yql console, a sample query will pop up. So it's really great to populate that so that people who are utilizing your table can quickly figure out what it's supposed to do. But what really tells Yql and the Yql service how to run a web API or web source is the bindings node. If we expand that out, we can see that we have a root select node here. You can change that to insert, update, or delete, whichever request you want to run. Select is usually the most common because not all web APIs might support that insert, update, and delete capability. We can specify an item path in there. So let's say I'm leveraging off of some external Yahoo data, Yahoo web API. Now, in the web API, in the XML structure that's returned back, or the JSON structure, we have this root node called top. And then underneath there, we have a child node called child. And then that's where all of our data that we want to leverage off of is. Now, everything above that, we don't care about. It's just diagnostic information. So we can specify the item path to drill down to top.child and utilize child as the root node. Very helpful. It's to mitigate a lot of the data that's returned back that you might not need from an external data source. Then we have produces, which shows whatever the XML or JSON produces. And underneath that, we have a URL structure. So the URL structure will actually be the URL that we're going to make the request to. So this is the external data feed, like an RSS feed. It could be a web API issuing the GET request. So you would specify the URL that you want to use. In this case, we just have some sample URL passed up there. Now you can see in the curly braces that there's a user value in there. Now when it's in curly braces, there's a special note about the URL. If we take a key value that we see right below there on the inputs and specify the ID as the same as that value that's in curly brackets, we can see that we can replace whatever's in that URL with whatever the user specifies. So when the user specifies select star from my table, where user equals whatever, the user value that the person specifies will replace into the URL, and then that new URL is called. So it's a good way of providing some dynamic value in there. So that's just one thing to know. Now, if you want to utilize these open data tables that wrap a web source or web API, you have a couple choices. You have the XML file. You can upload the XML file to our GitHub community tables at github.com/yql/yql-tables. Now this, you can just upload it there, and then we'll push it into our community tables. Or you can upload it to your own website and web service, whatever you have available, and use the Yql use clause. We'll hold questions for afterwards, but think. So method one, uploading to GitHub. At our GitHub location, you can just fork our repository, make the changes to the new table that you want, and push it up there. But I strongly suggest you don't use that for this hack event. Now, the reason is because you would need to push this request. We would need to insert it into our repository. Then we would need to manually update our community tables. Usually the process takes 48 hours. We do it once every 48 hours. I wouldn't suggest doing it tonight because you're in a hack, and you want to do this quickly. So method two is what you should use, which is the use clause. So in our Yql console that you saw, utilizing the Yql syntax, we can specify use the URL to our XML file, our XML config file that we created, as our table name, semicolon. Then you say select star from that table. It's a very easy way to quickly implement this technology. Now, we went through the specifics of Open Data Table. Now, let me quickly go over what execute does. So execute is our server-side JavaScript layer that's going to allow you to manipulate the entire data structure that's returned back to you very quickly. We load up our standard XML config file, loading up the bindings node, and where the execute layer is going to fit is right underneath the select node, just like the URLs and the inputs. Now, if we expand that out, we can see that it's server-side JavaScript. Wrap your server-side JavaScript in C data tags so that we can quickly and easily parse out the JavaScript as JavaScript and not confuse it with a Yql open data table. So that's why you wrap it in C data tags. So it registers it as actual JavaScript. Now, some of the things that you can do in here very quickly are things like what the user specifies in the actual console, or when they say select star from the table where, and all those where and or clauses, everything that the user specifies, you can get via the inputs associative array. So you say inputs and then the key value that you're looking for. You can also have native E4X support built into the server-side JavaScript layer. That means XML nodes can be built on the fly in JavaScript. Now, if you change the data structure of a root API or service, the data that's returned back, you can quickly change the response structure that's returned back from Yql using response.object. You can set this to a new node, you can set it to an empty node, you can set it to anything you want, but response.object is what's going to be returned back. Now, you can do so much more with Yql, like issue REST requests. You can run another Yql console or Yql request. You can filter data. There's a lot of stuff available on the documentation that if you're using the service, I'd recommend using. When I build out any advanced table, I usually cut out the URL and just do all my execution of the table within the server-side JavaScript layer. It's very helpful. So we went through all the items on Yql. Now, if you were asleep during the conversation, time to wake up. There's just a couple of notes to get the gist of what I was talking about. First off, for Yahoo services and Yahoo APIs, Yql is an amazing skeleton key. So you don't have to deal with all the APIs, data feeds, external data, getting the data out yourself. It can quickly leverage off of the data for you to utilize. And the open data table structures is a wonderful method. If we don't have an API available, if there's a specific API that's only available in Romania that has some specific Romanian history data or something like that you want to wrap, I would definitely suggest using open data tables for it. I can help you configure that very easily. The execute node is wonderful for manipulating the data that's returned back from an API before it's returned back to the user. So if you want to mash it up with some geographical information from our geotables quickly, you can do that. And finally, don't deal with OAuth. OAuth sucks as far as a hacker technology. You having to go through that in a 24-hour event is painful. It's a wonderful authorization system. It's a wonderful open authorization system, but it sucks for hacking quickly because it's a lot of signing. Don't deal with it. Use the SDKs. Trust me, it'll save you a lot of painful efforts, and it'll save a lot of trips to us for helping you through the signature issues. So some of the links that we're going to be leveraging off of, I'll provide the link to this actual presentation so you don't have to mark anything down. All the APIs and services that we offer within YDN that you can leverage off of using Yahoo is available at developer.yahoo.com/everything.html. Yql documentation is developer.yahoo.com/Yql. The console is /console after that. And then the GitHub account, where we would love to get your new API, your new open data tables, your new web sources, is available at github.com/Yql/Yql tables. Here's the link to the presentation. Should you want to download it, get all this information, a lot of the hack data that's available in here to get started very quickly. Here's my contact information. Twitter's a really good way of getting a hold of me. I'll usually respond back very quickly on a regular basis, unless I'm traveling. And then my email address is also a good method. So these are some of the great things about Yql, and honestly, it's replaced so much of my development. It's made my life so much easier, where I had thousands of lines of code to do everything from screen scraping to doing the OAuth process, et cetera, et cetera. Yql's replaced this, and it's done a better job than I could have ever done in my own development. You're leveraging off of tons of Yahoo cloud technologies here, the back end, that we could process data very quickly, return it back to you in a very streamlined way. You don't want to have to do this yourself. It's not worth it. Just just utilize Yql to make your lives easier. It's a free technology for you to use. Now, for any questions that you might have, we'll reserve them for now, but where these balloons are, the balloons are down. The reserve table that's just over there is where we'll be hanging out. Just look for us in green shirts. Almost all of us can help you out with Yql in some way or another. If they can't, they'll get someone that will. Now, I would strongly suggest that this is a technology that you explore if you want to leverage off of some external data feed. Thank you very much, everyone. It's been a pleasure speaking with all of you.